Have you ever worked in a system, maybe it's a rigid corporate hierarchy, or some specific software platform you were forced to use every day, or even just a local community project that felt like it was actively working against you?
Oh, yeah. Where it feels like you are putting in this constant, exhausting effort just to keep the whole thing from vibrating apart.
Exactly. Like,
Yeah.
if you stopped pushing, it would all just collapse,
Right, because you're the one providing the caloric energy to overcome the friction of the system itself rather than, the system doing the work for you.
which is such a frustrating place to be. And welcome to today's deep dive, because we are looking at a stack of case files, resumes, and white papers today centering on a guy named Clinton Alden.
And he basically figured out exactly why that exhausting friction happens.
Yeah, and spoiler alert, the answer isn't bad management or poor communication. It's actually physics.
It is entirely thermodynamics. Which sounds wild, I know. But when you review Clinton's trajectory through these source documents, you're looking at a career that spans hardcore enterprise software consulting on one end, and then, surprisingly, award-winning film production on the other.
It's a really specific, bizarre collision of disciplines.
It really is. But it's exactly that collision that led to the creation of what he calls the Cosmos framework.
Which is this unified theory of systems we are going to unpack for you today. It essentially uses nature's 3.8 billion years of evolutionary research and development to predict, like mathematically predict, whether human institutions will thrive or inevitably collapse.
And to figure out how he cracked that code, we really have to look at where he saw human-designed systems failing the hardest.
Right, which takes us to his time implementing Maximo. We're talking taking this massive enterprise software all the way from its DOS-based version 2.6 in 1992, right through Series 5.
Yeah, he spent over a decade as a Maximo evangelist.
And we are talking deep technical competencies here. Database engineering, custom integrations, PL SQL programming.
Heavy, heavy technical lifting.
Totally. And his track record in the source documents is flawless. 100% on-time, on-budget implementations with absolute giants. NASA, General Motors, ExxonMobil.
But despite all that technical success, getting the software running perfectly, he noticed this recurring, fatal flaw in how IT projects are fundamentally architected from the top down.
Right. He realized that C-suite executives, usually, MBA types, were designing these massive enterprise systems to optimize cash flow.
And in the process of doing that, they were entirely suffocating the workflow of the users on the ground.
Yes. Let's ground that in this one specific anecdote from the case files, because this just blew my mind. So Clinton audited a client and found that their administrative controls, basically the approval processes put in place by executives to track spending, were costing the company approximately $100 per purchase request.
Wow. Just in administrative overhead.
Just in wasted time, lag, and delays. $100 every time someone needed to buy something.
Because you have to look at the cost accounting of all the human capital. The time spent, opening a ticket, waiting for a manager's approval, routing it to finance, sending it back for clarification.
Yeah, all of that human energy. So the system was designed to prevent a $10 mistake, but it burned $100 of human energy just to move a single requisition from waiting to closed.
It's totally backwards.
So basically, the executives built a high-speed highway, but they decided to put a toll booth every 50 feet just to track the pennies. And ironically, the toll booths caused a $1 million traffic jam.
That is a highly accurate way to look at it, actually. Clinton termed this the thermodynamics of work. A system is only as viable as its usefulness to the people on the ground.
Right.
If an enterprise platform doesn't solve daily workflow friction for the actual users, those users will naturally find the path of least resistance.
They'll just bypass the software entirely.
Exactly. They'll keep separate spreadsheets, they'll use workarounds. Top-down enforced rules often violently contradict natural human workflow.
And if you try to automate a bad, high-friction process, you just make the system fail faster.
You're just speeding up the collapse.
Okay, but figuring out that top-down software is rigid and fails under pressure, that's one thing. Knowing why a system fails doesn't automatically tell you how to build one that actually survives human unpredictability.
No, it doesn't.
Like if you want to study pure, chaotic, real-time human collaboration, a server room isn't going to teach you that.
No, definitely not. And for that, you have to look at his time in the media industry.
Which is such a wild pivot. 16 years as a producer, director, cinematographer, and editor, 4 Telly Awards.
Yeah, he's working on national broadcast-level productions with major brands like Nike, General Motors.
Musical artists, too, like Jewel and Izzy Stradlin. He was even working alongside heavyweights from the Cruise of Traffic and Saving Private Ryan.
He's stepping entirely out of the highly controlled, deterministic environment of database architecture and into an environment that is just completely fluid.
Because managing a film set is basically managing a temporary high-stakes microeconomy, right?
Well, absolutely.
You have tight budgets, chaotic environments, giant egos, strict deadlines. You have 60 people who might have never even met before, and they have to collaborate instantly to produce a highly complex product. He was effectively testing system resilience in real time.
And if Maximo taught him about rigid structural architecture, the film industry taught him about what he later calls distributed agency.
Okay, break that down for me. How does a film set operate differently than a corporate hierarchy when it comes to agency?
Well, think about the moment a director yells action. The focus puller, the boom operator, the actors, the gaffer, they all have to possess the localized agency to make micro sounds in real time.
Right.
If the actor shifts 2 inches to the left, the focus puller has to adjust instantly. If that decision had to go up a chain of command to a central committee for approval, you would never get a single usable frame of film.
The whole system would just freeze up.
It would completely collapse under the weight of its own administrative control. Film sets survive because they decentralize decision-making to the edges of the network where the actual work is happening.
That makes so much sense.
And this dual background, the rigid logic of databases combined with the fluid distributed collaboration of a film set, was the necessary incubator for his theory. He realized both enterprise software and human microeconomies were just trying to mimic something much, much older.
Nature. Which brings us to the core philosophy of the Kosmos Institute of Systems Theory, which he founded in 2025.
Right.
The premise here is breathtakingly simple, honestly. Natural systems persist because they adhere to physical laws, specifically thermodynamics, and they have the benefit of 3.8 billion years of evolutionary research and development.
In the natural world, extinct species are just feedback.
Wow. Extinct species are feedback.
Yeah, extinction is nature's quality control mechanism. It removes architectures that burn too much energy or fail to adapt to their environment. Nature doesn't care about your business plan. It only cares about caloric efficiency and structural integrity.
So Clinton develops the Cosmos framework to apply this natural intelligence to human institutions. The white papers we have outline 4 main pillars to this framework. But I want to avoid just listing a bunch of acronyms.
Yeah, let's keep it grounded.
Let's start with the anatomy. The framework claims every functioning system has a universal structure.
Yes, the 7ES, or 7-element structure. It posits that whether you are looking at a single biological cell, a Fortune 500 company, or a global supply chain, a functional system always has 7 components.
Okay, what are they?
Inputs, outputs, processing, controls, feedback, an interface, and an environment. If you remove any one of those, the system degrades.
Give me a concrete example. What happens if a corporate department is missing, say, its feedback element?
Well, if a department has no mechanism to receive passive feedback from its environment, say a product team that literally never talks to its end users, it will continue processing inputs and generating outputs based on entirely outdated assumptions.
So they'll just build a product no one wants.
Exactly. In nature, a system without feedback dies. In the corporate world, a system without feedback requires artificial cash injections just to stay alive.
Which transitions perfectly into the second pillar, the FDP, or fundamental design principles. The sources describe these as 8 biomimetic ethics metrics. Now, I have to push back here a little bit.
Sure.
Ethics are inherently subjective, right? How can a mathematical framework measure something as subjective as corporate morals?
Well, because the Cosmos framework strips the subjective morality out of the equation entirely and replaces it with physical sustainability.
Right.
These aren't your traditional ESG or SDG metrics, which, often just boil down to performative reporting compliance. The FDPs measure thermodynamic reality.
So how do you measure that mathematically? Like, take one of the metrics mentioned in the papers, symbiotic purpose.
Symbiotic purpose asks a simple question. Does this system create mutual benefit for all participants, like cross-pollination between bees and flowers? Or does it extract value for a privileged few, like a parasite?
Ah, I see.
A parasitic system isn't just morally bad. From a physics standpoint, a parasite eventually kills its host, which means the parasite system is inherently unstable and doomed to collapse. You can mathematically model that energy drain on the host.
That makes total sense. Another one I saw is closed-loop materiality. Basically asking, are all outputs recycled as inputs, like a mycelium network in a forest, or is there systemic waste? It's literally holding a mirror of nature up to a corporation and asking, would a forest tolerate this process?
And the answer is almost always no.
Right.
Which leads into the third pillar, the designer query discriminator, or DQD. This evaluates the origin of the system. Did this structure evolve organically to solve a real problem, or was it artificially enforced from the top down by someone just seeking to extract value?
Right. It asks who actually benefits from the design. But the fourth pillar, this is where the framework gets really radical to me.
The OCF.
Yeah, the observer's collapse function. It measures belief dependence. The case files point out that a forest continues to grow whether you believe in it or not.
Right. Physics doesn't require your belief.
But a fiat currency, or a social media platform, or a corporate hierarchy.
Those collapse the exact second people stop believing in them.
Wait, so the observer's collapse function basically measures belief. It almost sounds like, what's that called? The Tinkerbell effect, where if the audience stops clapping, the fairy dies. Is he saying a Fortune 500 company operates on the exact same logic as Peter Pan?
It is exactly the Tinkerbell effect, but quantified mathematically.
That is wild.
Human institutions are incredibly fragile because they are almost entirely belief-dependent. They require constant active enforcement to maintain their boundaries. Clinton's whole mantra is, physics does not negotiate. Ideologies, political preferences, MBA buzzwords, thermodynamics doesn't care about any of them. The OCF calculates the exact amount of energy a system is burning simply to enforce belief and compliance.
So if the OCF score is too high, the system is spending all its energy just keeping the fairy alive, and it has no energy left to actually adapt to the real world.
Precisely. And this is how the Kosmos framework evaluates if an organization is genuinely transforming or just changing.
What's the difference?
True transformation means restructuring the core architecture to survive according to physical laws. Change is just incrementally optimizing a dying extractive paradigm.
Like rearranging the deck chairs on the Titanic.
Exactly.
Well, the unified theory with cool acronyms is fascinating, but a framework is only as good as its predictive power. Clinton claimed this math could predict institutional collapse. And looking at the 2026 validation documents, there is a very specific high-profile case study regarding the Department of Government Efficiency.
Yes, and we should pause here.
Yes. Stepping entirely outside the politics of this, we are taking no stance here, just looking at it strictly as an objective thermodynamic data point reported in the source documents.
Right. Clinton audited DOGE in August 2025.
Okay. And what happened?
The audit applied the framework to the department's structure, and the Kosmos tools scored its observer's collapse function at maximum collapse risk.
Why? What was the underlying structural flaw?
Extreme centralization. You had a massive, complex initiative that relied almost entirely on a single enforcer, Elon Musk, with virtually no localized feedback responsiveness. In thermodynamics, when a system's architecture can't distribute its processing load and relies on one centralized node to enforce all the rules, it becomes incredibly brittle.
So the framework predicted a cliff collapse within 6 to 12 months, meaning it wouldn't slowly degrade over years, it would just snap the moment the enforcer was removed.
Exactly.
And according to the timeline in the sources, 3 months later, in November 2025, Musk departed, and the system instantly collapsed.
It is a textbook example of prospective predictive confirmation. The framework diagnosed the structural flaw, established a timeline based on energy expenditure, and the system failed exactly as modeled.
That is kind of eerie. But the framework didn't just work on federal bureaucracies. The most surprising validation in the sources, for me at least, happens at the human clinical scale.
Oh, Dr. Eric Whitney's work.
Yeah. An osteopathic physician independently used the exact same OCF math to diagnose human trauma.
He was searching for a mathematical threshold in his practice, a way to objectively determine when non-invasive therapy is sufficient versus when a patient requires clinical intervention.
But how does an equation for institutional collapse mathematically apply to a human nervous system? I'm struggling to connect a government audit to psychological trauma.
Well, think of the human nervous system as a processing engine within that 7ES structure we talked about. Its primary job is to take inputs from the environment, process them, and generate an output.
Okay, following you so far.
When a patient has severe unresolved trauma, that trauma acts as a rigid, artificial control mechanism. It requires massive amounts of internal caloric and psychological energy just to suppress the memory or to maintain a functional outward identity.
Oh, wow. Because the energy is being spent on internal compliance. instead of adapting to the external environment,
Uh-huh.
just like a company bogged down in administrative friction.
Exactly the same mechanism. Dr. Whitney realized that a traumatized identity requires constant enforcement to maintain because it conflicts with the patient's original healthy biological architecture.
So it scores incredibly high on the observer's collapse function.
Yes. Under enough external stress, the patient can no longer supply the energy required to maintain that artificial structure, and they suffer a clinical collapse.
That is absolutely
It's a
staggering.
breakthrough in viewing psychology through a physics lens.
And then the sources detail the other end of the spectrum too,
Yeah.
the AI scale. A software architect named Ethan was building an artificial intelligence.
Yeah.
He needed it to survive in highly volatile, hostile digital environment.
Right.
So Ethan didn't read the Cosmos white paper and explicitly program a 70S structure. He just threw an AI into a digital meat grinder to see what it would do.
And to keep the AI stable in a hostile environment, he organically started writing code to handle unpredictable variables.
Yeah.
Through pure trial and error, he ended up coding diverse sensory inputs, distinct parallel processing agents, rigid control parameters, and active feedback loops.
He accidentally built the 7-element structure.
He proved that the 7ES architecture emerges naturally out of necessity when a system is under pressure. It isn't a theoretical model, it is the default structural requirement for survival.
Wait, let me just pause here. If the math for a failing government initiative is identical to the math of human trauma and identical to the architecture of artificial intelligence, then human institutions aren't just like living organisms. Structurally, thermodynamically, they are organisms.
Yes. That is what systems theorists call scale and domain invariance.
Scale and domain invariance.
Whether you are observing quantum physics, an individual human nervous system, a piece of software, or an entire civilization, the thermodynamic rules of systems are identical.
That's incredible.
If a system lacks passive feedback, or if it relies entirely on forced compliance rather than mutual benefit, it is burning energy just to maintain an illusion. Eventually, it will fail. Gravity functions identically across all human systems, regardless of whether a CEO or a politician acknowledges its constraints.
That fundamentally changes how you look at every organization on Earth. But, it's also incredibly easy to point fingers at other failing systems, right?
Oh, sure.
It's easy to audit a corporation or a government and say, hey, your architecture violates physics. But Clinton did something highly unusual in the consulting space. He turned the microscope on his own institute.
The reflexive self-application phase.
Yeah.
In October 2025, the Kosmos Institute used its own web tools to audit itself.
And they didn't get a perfect score. They actually scored a 6.8 out of 10.
They classified themselves as a hybrid system. Not fully natural, not entirely artificial, but vulnerable.
The audit revealed they were entirely too centralized around Clinton himself. Their distributed agency score was only 4.5 out of 10.
Right, which means they effectively had a massive single point of failure risk.
Yeah, if Clinton stepped away or got hit by a bus, the entire institute would trigger its own observer's collapse function.
Now, in traditional consulting, you bury that report. You put it in a locked drawer because admitting structural weakness damages your brand authority.
But instead of building a black box to guard his secrets, Clinton published the mediocre score for the whole world to see.
He open-sourced the tools?
Yeah, he put the Cosmos methodology on GitHub. He created a free web tool so anyone could run an audit on their own organization. He decentralized the institute's structure, distributing the agency out to the community.
And by restructuring their actual architecture, rather than just changing their marketing, they improved their global score to an 8.0 by April 2026. They crossed the mathematical threshold into a natural system classification.
He open-sourced the blueprint to prove it works on himself.
I love that.
It proves intellectual honesty, which, by the way, happens to be one of the 8 fundamental design principles.
Oh, really?
Yeah. By doing to themselves what they demand of their clients, they demonstrated that biomimetic repair protocols actually create genuine, measurable resilience. The framework distinguishes genuine transformation from performative compliance because you literally cannot game the math.
The scores only shift when the underlying architecture actually changes.
Exactly.
Well, we've covered a massive amount of ground here today. We started with the frustrations of DOS-based enterprise software in the 90s, where executives strangled workflow with administrative toll booths. We explored the chaotic, distributed microeconomies of film sets.
Right.
And we arrived at a unified theory of systems that uses nature's 3.8 billion-year-old cheat codes to diagnose everything from artificial intelligence to human health. It represents a profound shift. moving away from subjective, culturally dependent moral frameworks and toward the objective thermodynamic measurement of systemic sustainability.
But why does this matter to you, the listener? Why should you care about the thermodynamic efficiency of a corporate structure? Well, because you exist inside dozens of systems every single day.
We all do.
Your workplace, your local community, your family dynamics, your own daily routines. You now have a new lens to evaluate your life. You can look at a relationship or a job and ask, is this system regenerative and mutually beneficial? Or is it extractive, burning unnecessary energy and mathematically destined to collapse?
Are you coasting on natural intrinsic alignment, or are you constantly fighting systemic friction?
So we want to leave you with a final thought to ponder. Take a hard look at the systems in your own life right now. The way you work, the way you manage your time, the communities you participate in. Which of them are coasting on intrinsic natural stability? And which ones are only surviving because of your exhausting constant enforcement? If you stopped applying effort tomorrow, if you stopped clapping your hands to keep the ferry alive, which parts of your life would trigger the observer's collapse function and simply vanish?